All right, today we are doing lessons 4 and 5 of Unit 3. And really, the only thing we're adding is this stuff at the bottom here about the fractional exponent rule. We talked about yesterday how square rooting is the same as having a power of 1/2. Cube rooting is the same as having a power of 1/3. Any time that you have a exponent of 1 over a number, that tells you the root. So a fourth root would be 1/4, fifth root 1/5. So that tells you the rule when your numerator is 1/2, 1/3, 1/4. But what happens if the numerator is anything other than 1? And that is what this fractional exponent rule is going to talk about today. So it turns out the denominator is still going to be your root. Okay, your denominator is still going to be your root. So if your denominator is 2, it will be a square root. If your denominator is 3, it's going to be a cube root, so on and so forth. But the numerator is going to tell you what the exponent is, okay? And that exponent could go inside or outside the root. So to show you what do I mean by that, I'm going to go to the examples. So we're going to write the following using roots, okay? So which means there's going to be some sort of root. Now, when I write a root, okay, I always put out here, like if it's a cube root, I write that. If it's a fourth root, a fifth root, so on and so forth. The only time I don't have to write the root is if it's a square root. If there's no number outside here, we assume it's a square root, okay? So we're going to write it like this, okay? So now we have to account for this exponent of 2/3. So if we look at our lesson notes, okay, the denominator tells me the root. So the denominator in this case is 3, which tells me it's going to be a cube root, okay? The numerator, which in this case is 2, is the exponent. And that exponent can go inside or outside the root. So what do I mean by that? So I could write the exponent of 2 here, where notice I put it inside the cube root sign, or I could write it like this, where I put the exponent outside the cube root. Either one is correct. So when you write 5 to the power of 2/3 using roots, either one of these would be considered correct. So if I was going to do the same thing for number 2, okay, notice when I look at the exponent, notice the denominator is the same. So I'm still going to have the cube root of 5. The only difference is now my exponent is going to be 4. So again, I could write that exponent of 4. I could write it inside the cube root, or I could write it outside the cube root. And that is the answer for number 2. Okay, number 3, 5 to the power of 3 halves. Okay, again, the denominator, which in this case is 2, tells me the root. So this tells me that it's going to be a square root, okay, which means I don't need to write square root outside of that, okay? Just by writing the symbol like that, it implies that it is a square root. Okay, so the denominator is 2. That tells me the root, that it's a square root. Okay. And then the numerator, which in this case is a 3, is the exponent. So the exponent in this case is 3. So I could write that like that, where the exponent of 3 is inside the square root, or I could write it where it is outside the square root. So the square root of 5 cubed. Okay. Now if I compare 3 and 4, okay, notice the numerators are the same, right? So that tells me that the exponent is going to be cubed, just like in number 3. Okay, just like in number 3. So that is not going to change. What is going to change is the root. The denominator in this case is 4, so that tells me this is going to be a fourth root. So the fourth root of 5 to the power of 3, the fourth root of 5 cubed. That is all we're doing for the first 4 questions here. Okay. For number 5 and 6, we're basically going in the opposite direction. So we want to be able to go from exponent form to roots form, but we also want to be able to do the opposite. So we want to go from roots form to exponent form. So for 5 and 6, we're going to rewrite that using exponents. Okay. So with that in mind, we know it's going to be a 5. Okay. So notice the root here is the fourth root. So remember, the denominator of the fraction gives me the root. So the denominator of the fraction is going to be 4. And then by process of elimination, the exponent is going to be, or the numerator is going to be 7. So writing that using exponents is 5 to the power of 7 fourths. Okay. And then for number 6, okay, again, notice if I look here, there's nothing there. So that tells me it's a square root, which means the denominator is going to be 2. Denominator tells me the root. And then this is going to be a 9. So 5 to the power of 9 halves. Okay. Your cool down is going to be a couple like number 1 through 4, where you're going from exponent form to roots form. Okay. And then the last couple on your cooldown will be like 5 and 6, where you're doing the opposite. Now, one thing I want to make you aware of, so you don't get confused on the cooldown, okay? On the cooldown, you're going to see the word radical, okay? Okay, radical is just a fancy word for roots. So when it says, if it says to write it using radicals, that means write it using roots. So radical is just a fancy word for roots when you see that on your cooldown. That is it for lessons 4 and 5.